So the final part of this lesson is going to cover the test driver implementation, and then we're going to run it and see how it performs. And we'll show the performance of both parallel and sequential implementations where they can be applied. So let's first talk a bit about the QuoteDriver class. Now, unlike things that we've talked about up to this point, where we had a test driver which was a Spring Boot test, where it would automatically start up the one and only service to test, we can't do things quite that way here because we've got multiple microservices. So instead, we're going to make ourselves this QuoteDriver class, and we're going to define it to be a command line runner. You can see it extends or implements the CommandLineRunner interface. And because of that, it gets a method called run. And you can think of run as basically emulating sort of a console-based command line style interaction where you can actually have it interact with the program that's running microservices on the console, if you will. And that basically has all the logic that does the calls to the microservices, and it times how long it takes to fetch quotes and do various things from the Zippy and Handy controllers. And here's the command line runner. You can see here this is an interface which has a run method that we have to implement. One of the interesting methods here is called time Zippy quotes caching, and it demonstrates the benefits of server-side caching by making the calls twice. The first time it calls the methods, they will go ahead and do the work, and I put a 4-second delay in there just to demonstrate what they're doing. And then the next time you call them and the subsequent times you call them, they just return the results. So most importantly here would be things like getting the quotes, because that doesn't change, so we can cache that. So we're going to see the benefits of caching, which are quite dramatic. There's also a method that times how long it takes to fetch quotes from the Handy service, and this is going to do searches, and it'll compare sequential and parallel execution. And there's something similar for Zippy, so we're going to time those as well with parallel and sequential execution. And then there's a method that both the time Zippy quotes and time Handy quotes use called run quotes, which factors out the common logic for doing these operations and will run in parallel or sequentially. Okay, so I'll show you this in a second, but here's what you have to remember, because this will be very important for assignment number 2, because you will need to auto-launch the gateway application, the Eureka microservice, the Handy application, the Zippy application. All of these things have to be started up before the client driver program can be run. And we're going to launch these manually using IntelliJ. Not the way you would do it in a production system. You'd have some scripts, or you'd use an orchestration mechanism like Kubernetes or Docker or whatnot. But just for this example, we're going to keep it simple. And once everything's up and running, then we can run the command client driver as a command line program. And it'll print the results. So it's going to make a bunch of calls, and it'll tell us whether they succeeded or failed, and it'll also time how long it took to run. And the client will print the results. It gets back from the API Gateway in the console window. And I should also point out very quickly that I misspoke earlier. When you use the gateway pattern with Spring, the gateway is responsible not only for taking requests from the client and routing them to the microservices or microservice, it also takes the results that come back from the microservices and then forwards them back to the client. So the API Gateway is the central mediator that does all the communication between clients and microservices. So microservices never talk directly back to the clients. So let's go ahead and take a look at how this works. So here we are in the client folder in my EX4 project, which resides in the web MVC folder in my live lessons GitHub repository. And let's go take a look at this and see how it works. So you can see here that this is not a Spring Boot test. It's an application that implements the CommandLineRunner interface. And as a consequence, it's going to have a run method that does what it needs to do. It has a number of quotes to request. It's got an auto-wired quote client. We parse the command line arguments, if any, and then we run the application, which we'll turn around and call this run method here. And first thing we're going to do is we're going to time the Zippy quotes caching. And you can see the way this works is we're going to make 2 calls. First, we're going to do an uncached call to get all quotes. And then we're going to call it again This time it will get the results of caching, and so we'll see how long that takes to run because we time these calls. And then we're going to do something similar where we're going to go ahead and get a particular quote, which is a random Zippy quote at a random Zippy quote ID, and we'll do that again twice, once using caching, once not using caching. While I'm talking about this stuff, let me go ahead and start the microservices in the background. So I've got a little script that I have here. And if we take a look at the script, you can see that it's going to run the Eureka application first, followed by the Gate application, followed by the Zippy application, followed by the Handy application. Once we get the Eureka application up and running, then I think we can do these in pretty much any order, but I like to do it in a particular order just so I can keep track of what's going on. So when we click this particular tab, it's going to start the different microservices. You can see the Eureka one is starting up first. We can also run these by hand. So if your platform, if your version of IntelliJ doesn't support the multi-run features, then you just have to start these up one at a time. And you can see here what's happening is it is starting up the microservices, starting with Eureka. You can see that Zippy is being registered here. And you can see the Gateway application has also been started up. Gateway application is listening on port 880. Zippy application is starting up. Let's look at Handy first. The Handy application is one that's hard-coded to run on port 9100. So we hard-coded that. The Zippy application, in contrast, uses Eureka, and so it selects its own port number, which in this case is 52,197. That doesn't really matter. All that matters is it registers that with Eureka, and you can see if we go look over at Eureka that these microservices have registered with it. And now that we've got everybody up and running, we can actually run the client. So let's run the client while this is happening. So I go and select QuoteDriver, and now I'm going to run that. You can see that I've got the Eureka application, the Gateway application, the Zippy application, and the Handy application. They're all up and running. They seem to be successful in starting up. And we're now going to go ahead and run the client. So this is acting as a command line, if you will. It can interact with the API Gateway. And as you can see here, it makes all these different calls. I check the results to make sure they're what I expected. They are, which is good. And then this shows you the timing results sorted by fastest to slowest. And what you can see here is that the uncached calls to get all the quotes and get a particular quote took a little bit over 4 seconds to run, which is what we'd expect because we put a 4-second delay in there the first time. But if you take a look at the second time they're called, they take almost no time to run at all because that data was cached. So you can see that those things are cached very, very fast compared to the ones that took longer. And then these are just doing the other ones and timing them. If you look here, I'm not sure if there's really rhyme or reason to the timing. It looks like some of the sequential stuff takes longer than the stuff that runs in parallel, but we'll talk about that later. So continuing on with our discussion here, that's what the cached version of this stuff does. It tests that. Then we go ahead and record the time it takes to get the Zippy quotes, either sequentially or in parallel. Do the same thing to take how long it takes to get the Handy quotes, either sequentially or in parallel. Let's go look at the Handy quotes. This is really pretty much exactly the same code. What we do here is we use the parameter that's marked as parallel here. So it's either going to be parallel or sequential. We invoke the operation passing in that flag. So the microservice will run either sequentially or in parallel. Notice we call the run quotes helper method here, passing in the microservice we want to do the work and whether we're running in parallel or not. Here's the run quotes method. This is the one that factors out the common code. And you can see what it does is it makes a call on the quote client, which in turn uses the proxy, which in turn uses the quote API generated by retrofit to make a call to the get all quotes endpoint on the appropriate quoter microservice, so either Handy or Zippy. And once we get back the list of quotes, then we're going to take that list of quotes and we're going to make random indices up to that many quotes, and then we're going to go query to get the random quotes. So that's what the post quotes thing does here. It goes ahead and takes the random indices and makes those calls in parallel. So that's how we're using run quotes here. And then the other thing we do here is we make a list of common words in the handy quotes: dad, man, gold, stuff, poor, cry. Those are some common words. And then we go ahead and search for any of those quotes and get the results back. And then we do a similar thing where we look for man and that, and then we search for things that have all those items in them. And it turns out that there is, in fact, one that has both man and that in it. Kind of strange, but that's what it does. And we do something very similar for Zippy, where we're going to go ahead and look for some of the famous Zippy phrases like yow and pinhead and fun. Those are Zippy phrases that sure turn up a lot. Waffle, he loves waffles for some reason. So we go look up Zippy, and you can see we find a lot of things that have those words in them. And then we look up yow and yet, and we see what contains both yow and yet. And as you can see, there are 6 Zippy quotes that contain both yow and yet. Whoop-de-doo. And so that's what we display there. So that's basically how this program works. Make sure you're familiar with what we're doing here, because this will be very important for assignment number 2.